Welcome to today's webinar. Today is a special webinar as two software companies are working together, hsbcad and Dlubal. The topic of today's webinar is the data exchange between hsbcad and RFEM. My name is Gerlinde Schubert. I am the moderator of today's webinar. You will only hear me at the beginning and at the end. I welcome our external speaker from hsbcad. This is Bruno Bortot. He is responsible for technical support at hsbcad and he holds a Master of Science in Timber Engineering. Bastian Kuhn will work in RFEM today. He is the product engineer responsible for all the timber add-on modules in RFEM and Erstab at Dlubal. He is also supporting our customers in all timber-related questions. He holds a German diploma in civil engineering. The data exchange is shown on an example, which is a timber building construction with surface structures. You see a picture here on the right-hand side. The modeling is done in hsbcad by Bruno. He will also export the model. And Bastian will then take over and import the files into RFEM. He will also do some further modeling and load definitions and finally designs the timber construction. This is the control panel from GoToWebinar. You can show and hide the control panel by just clicking on the orange button arrow up here. And this is important down here. This is the chat option. You can ask questions. Please do not hesitate to ask questions. Bastian and Bruno will answer them as quickly as possible during the webinar. So I hand over the screen now already and the word to Bruno, and enjoy the webinar.
Good afternoon. My name is Bruno Bortot and I am technical support for hsbcad, and I'm going to be in charge of the modeling of a timber structure which later will be exported into Louisville. Let me give you a brief introduction about hsbcad. hsbcad provides a software solution for the design, manufacture and construction of timber structures. It works inside of an AutoCAD environment, and its modules includes timber frame panels, C-panels, CLT, log construction, glulam, and post and beams. Apart from the design, hsbcad allows the user to create export data for manufacture and production control. If you want to find out more about hsbcad, please visit our website here on the screen. Website address is www.hsbcad.com. So you can explore more about the solutions that we can offer. As I was saying, we cover all from all aspects of the timber structure plus CAM. Okay, now let me go back into our presentations. As I mentioned before, this runs inside of AutoCAD, in this case AutoCAD Architecture. What you see here on the left side of my screen is what we call the console, and you can group, you can nest inside the console different elements and turn them on and off as per your convenience. In order to simplify this presentation, I have created a footprint of what my building is going to be like. Basically, I'm going to create walls following the perimeters, and on top of that, I'm going to add my roof structure, which is going to consist on loose elements, loose timber elements. In order to create my walls, I'm going to select the group called Walls here on my console. I'm going to click on the button Place Walls, and I'm going to select the wall style I'm going to use. We'll say OK. And I'm going to follow the perimeter of my building. Okay, as you can see on the console, every single panel has been generated and I can turn them on and off easily. Okay, what I will do next is adding some openings to my building. I'm going to start adding some windows. I'm just going to follow my footprint. And I'm going to add some doors. So this is how my model looks like so far. Following to that, I'm going to convert these walls, which at the moment are nothing but AutoCAD walls, into CLT panels. With this tool called Create Panels, I have this window, and I'm going to select from the catalog the type of walls I can create. In this case, I'm going to create a 5 layers CLT panel. I accept. I select all my walls, and as you can see, my CLT panels have been created. The next step I'm going to take is creating the roof structures, which will consist of loose timbers and rafters. In order to do so, I'm going to define my roof plane. The roof plane will be defined from here, on which I specify the values A, B, and C, which are pitch of the roof, overhang from my reference line, and height at the eave. These values have been already preset for simplicity. I will accept. I will follow the perimeter of my building. And as you see, the roof plane has been already generated. Once I have done that, I'm going to create the purlins. Sorry, the rafters I meant. So I'm going to select rafters. I'm going to select the roof plane. I'm going to specify name, height, width, material, grade, and spacing. I accept that. I'm going to select my starting point and the end point. After that, I'm going to create the purlins that will support those rafters. We'll select my plane again. Once again, all these values have been already preset up, but basically you need to fill all this information. The pictures are quite self-explaining. We'll say OK. Now I'm going to create that column that supports the purlin. I'm going to select that command there. I'm going to select my purlin, and I'm going to position the column as per planned. Let me show you now how the model looks like so far. Now I'm going to create a tenon and mortise connection to connect my column to my purlin. Using the visual tools included in hsbcad, I'm going to select one of the most convenient tools, in this case tenon. I will accept. All these values have been already predefined for the sake of this example. I will accept this. I will select my column. I will select my purlin. And as you can see, the tenon and mortise has been generated. Now what we're going to do is the foot of my column. I'm sorry, the tool of my columns is what we call a TSL. Okay, in this case I'm going to use a standard foot. We'll say OK. I'm going to select my column. And that has been created. So, in order to, all the model already has been created, what I will do now is adding some dimensions. So, as I said, in the console I can turn on and off whatever I need as per my convenience. So I'm going to turn off all the construction and I'm going to turn on just the walls. So I forgot to add this to the group. What I will do now is adding some dimensions. These are normal AutoCAD dimensions. If you want to see the layout, how it looks like, we have predefined layouts. So you can see the whole building. We have the plan, isometric view, an isometric view of part of the building, and some details as well. Of course, you can export that into manufacturing and create individual shop drawings of every single element, but that is beside of this presentation, so I'm going to omit that one. What I will do next is preparing the data for exporting into Dlubal. The first thing I'm going to create is the data of my beams and posts. So I'm going to turn off the walls. Okay. I'm going to turn on the columns. Sorry, I'm going to turn off the dimensions. So the only thing I have at the moment is my beam and post. What I will do next is create a structural model. So I select all my beam and posts. And as you can see, all the nodes and bars have been created. These nodes and bars will be later now exported into Dlubal. I'm going to add these nodes and bars to a convenient group. This is going to be this one here. Okay, following that, I'm going to export all this with this extension, STP import into Dlubal. I will accept. I will select all the beams. You can give some tolerances. That tolerance has been predefined and we have tested that works. And I'm going to create the DSTB file. Okay, that has been created on the main folder, which is that file there. Following that, I'm going to create the same file for the walls. My mistake, it's not the same file, it's an IFC file, which for the walls works better. So I'm going to create from this icon, IFC, select all the panels, now if you go back to the folder, that file has been created. You can explore that file. And that IFC file can be exported into Dlubal. You have the description of every single panel. From here. Having created these two files, which are the ones that Dlubal needs in order to proceed with the demonstration, I will leave my colleague to carry on with this presentation. So I will give this to Bastian.
All right, thank you, Gerland and Bruno, for the nice presentation. Also pretty impressive to me, and welcome everybody also from my side. The first thing what I'm going to do now is that I will import the HSB IFC file that Bruno has exported to me via drag and drop to our program. Okay, with this option I'm able to create a CID BIM model. This is done by a coordination view 2.0 import. We are certified for the 2x3 interface with that, and actually what it does is that it generates an analytical system from a physical system that we get from the hsbcad software. I will create the combinations automatically according to the standard for the United Kingdom and create the structure. So these are the etched files I got from the hsbcad, and now that I enabled the CID BIM module, I'm able to control all the elements that are in the structure. If there would have been parts that are not usable for me, I could deselect several parts. This is all controlled via this box here. And now that I have just walls, which is perfect, which is the one that I needed from the other software, I can right-click on these files and create a surface. I will not care about the material right now. If I would create concrete or steel structure, I can go to our database here and create a new material, but I will do that later on with our laminate module just in order to generate the stiffness on it. Say OK, and then I got the structure here. This is now the analytical system I can work with. It has no material right now, and all the corners are moment stiff for the rotation. These are things I must look for right now. The first thing I will do is to add some support to the structure. I will just create a linear support fixed in all directions. There are a lot of other webinars and videos where more detailed is explained what to do with the CLT construction or for what point you should look for. We are not catching that so detailed now in this webinar, so that's going to be rather a rough implementation of it. Then the next step is that I will add line hinges to the structure, because as I said, here in the corners it's moment stiff. It's also possible to define here some slip in X and Y direction, usually on a CLT plate, but as I said, this is done in a separate webinar where I also mention how to generate the stiffness in all the other parts of this. Then I will select the first surface, and on these lines I will generate this hinge. There's no slip right now, so that's just a hinge. And then this one, this one, this one, this one, this one. And so the corners are free now, and this here will actually be the last one. I will create a hinge. Okay, so that's done. Have a little check. That works. Another check that I can do right now is that I will generate my FE mesh just to see if it's looking good. Let's say 50 centimeters is a little bit too much. Let's say I will use 30. Go with that, so that looks acceptable to me. Maybe a little bit too rough here, but I think that would be okay. And what I'm doing now is to add the roof to the structure. This is done, as Bruno already mentioned, via the STP interface. Therefore I go via File, Import, and here I have all the options to import all the formats that we are able to import. And in the detailed settings of the STP interface, I have also a so-called mapping file. Maybe I can explain that a little bit. When you look for the file that I got from Bruno, there is another name for the material, and on a lot of other softwares it's also possible that you got other profile names, which is clear because the CAD software has a lot of other regulations to control with than we as a static software. And here you can create this mapping file with the informations that we need. You see, we would need for our, especially for the steel profiles, we need a lot of informations that a CAD software does not have to care about. And these things can be done in here, just as an information. Then I will catch this file, say open, and create that as well. In this case, I will not have to create the combinations automatically because I'm going to combine all the files together in the first model, in the first file that I created. Say OK, and now the structure is here. And now the intelligence of the hsbcad software has regarded that there is an eccentricity in between the beams, and therefore this is generated here, and I do not have to care about that anymore. Also the profile informations and also the grade of the material did come over from the other software. But it's not 100% ready yet because this is moment stiff. It is possible to define also a hinge in the hsbcad software here. You can say I have a moment rotational free hinge on this side, on this side. It's controlled via the letters 0, 1 and -1 in the hsbcad. Well, we decided to show you how to do it in our software because it's not always clear on which side you want to assign the moment release. In this case, I will decide, okay, the rafter, if we look for the rendered model again, has to turn around this axis. I will display the elements one more time and therefore go to where the members and display the members axis, and I want to rotate the rafters around the axis, the local axis Y. Okay, that out, that on here. And now if I go for views, member types, coupling, can just control the couplings here, select them all, right click, say edit, and change this member type to rigid just to make it more simple. And now that I looked for the orientation of this beam type, define the moment hinge around Y here. Okay, and now that's ready for me. And I can combine that into the other model that I have. Control C, I put it into my file, and Control V is the import. And now it's there. If you look for the Y direction right now, you see that in the connection of the beams and the surface, there is still a little problem. There's this little distance here. I need to copy the structure a little bit down to the other one. go here and say, okay, I just want it in X and Z direction, and then it's there. I have a little, yeah, discrepancy, a little distance here on this side. I have to check, and that can be also done via this control. And here say node edit and make all the X directions on the node the same. And even the same is here. That would work without it, but it would be a little bit too much on the safe side because you have this little distance in here between. That is something you probably will not want to have because the load introduction into the walls would be very high, and it would be on safe side for sure, but it is probably not very economic in the design, and therefore I will also make all these nodes in the same range and edit X direction V. Okay. So, and if you look for it now, you see that, oops, no, I was here. That looks much better. I will probably have a pretty high load introduction here. I show you also a little trick how to avoid that. And at first I will connect all the lines together so that they are really integrated into these elements. So if you look now, it is completely integrated there. And here I will actually make a small moment hinge as well at the end, just to not have such a high load introduction here into the structure. What still is a little bit critical to see is that here the purlin goes completely over the wall, and there I would also like smooth my results a little bit because there will be a critical singularity point, a peak I will have that can be avoided. In reality, you would probably define an average region here and here, like in every edge of it, but now I will just do it over the complete edge here, just to have it quicker. Wire, hold on, results, average region, and it will go to this, and this surface. I use circle, and I will use a pretty big distance, like 1.80 meters, just to, I tell you the reason later, just hold on, I will pick the node. Here you can see it already. I picked such a long distance because I will have also a singularity point here, and I will smooth all the results over this complete area. That's why I use such a pretty big distance. There, hold on. So that's what I wanted. And now if I want to go over all these elements, I can define a vector, 25 meters through all surfaces, say OK, and then you see this is generated. Now that still is no material, that's not existing wall, or a wall without a material, and it is not loaded. So at first I will load it with the self weight, and via tools generate model, generate loads via plane, generate some load onto it. I will pick the corner nodes in the structure here, here, and here. Say okay, I will use 1 kilonewton per square meter. Say okay, and then the load is generated. You can control how the load is assigned to the structure. If you display the load separate, you see that just on the rafters the load is designed. Yeah, but you will get a nicer picture for the printout report, and also for the calculation it is faster if you do not separate those loads. That's why we stay on this. Here, next step is that I will generate some snow load just to have something below an altitude of 1000 meters. Go also via the generate load function, snow load Eurocode, use the United Kingdom. You've seen that, maybe I go one step back, go here to tools, generate loads, snow load, that we are able to calculate according to American standard. There's a special thing in the Spanish annex, that's why we kept this as an extra annex here. well, the old DIN is there and the Eurocode, and in the Eurocode you have, I would doubt it to say all, but probably nearly all annexes you could find. If you're missing one, we can just implement it. Just give us an email and we will implement it. We will choose the, well, Cambridge, for example, and it gives us the zone number there. The roof geometry is like loaded from the load case 1 that I just generated. So I do not have to pick it one more time if I want to load the same stuff. And here I have the snow zones with all the loads. You know, there's the, on the top of the roof it is a little bit lighter, and if it's not so steep, which we have right now, use the factor 0.8. This is all regarded by it, and just to have 2 load cases, I will create a wind load. There must be, even on such a structure, 8 wind loads generated according to Eurocode, but now I will calculate this 1 load case. It goes with the same intelligence, vertical walls. It has also the same norms, all the things that I said for the snow load counts here as well. Oh wait, I was in Germany here, hold on. United Kingdom, wind zone, and well, there's probably some more wind in the United Kingdom than here. So now it is important from which side you start to pick the nodes. That's why I do it one more time now, just to show you how it works. So if I start with this edge point here on the bottom, go to this side, and now there's this little post where I also have to interpolate a little bit. Just, you know, this structure is not possible to load with the wind according to the Eurocode, so you have to, like, yeah, calculate a little bit on the safe side. That's why I choose this outer node here and not the inner nodes. And then the area I will load is, yeah, much bigger. Something that we have implemented pretty new, I would say for 2 years or something, is now the possibility to regard the roof overhang as well. So when you pick the nodes on the outside, it will actually also regard the wind that's underneath the rafters here on the roof overhangs. So you know that there will be wind in other directions than on the top of the roof. Okay, this, and I will create the surface loads on it, and there counts the same thing. I have all the factors for the pressure coefficient. That's all in there, and it's much more detailed explained in a webinar we did especially for this topic. Okay, the wind load is generated. A quick look into the load combination expressions. I will just concentrate on ultimate limit state, not on the serviceability. I will do an analysis according to first order theory, and this gives me this load combinations that are done automatically. And now I will create a stiffness in the add-on module laminate. There's also, as I said, a webinar especially for laminate. I will choose the standard. That counts also the same as for the snow load, or similar the same. I will choose the United Kingdom and put my result combination into the module. As material characteristics, I will choose, well, we'll probably choose Binderholz, but just to show you what kind of producers we have available here. This is the range of producers we have right now, but we are currently implementing more and more producers to this database. Choose wall, and I will choose actually a 5-layered plate because the load introduction to it is a little bit better than if I had a 3-layered plate. Select the walls I want to give this setup to, and now look a little bit for the orientation of the layers, because that's also pretty important. You see that this is not completely right what I do here, because the X orientation, the highest stiffness of this plate, goes in horizontal direction on the first layer of the plate, and the second goes in vertical direction. That's not how you would do it in reality. In reality you would do it different. You would do it 90 degrees on the first layer, horizontal on the third, so that is more like you would do it in the reality. because now for the buckling you have the higher stiffness in the vertical directions. Okay, just a little estimation. And just to show you what this average region is able to do, I will not activate it right now. So I will calculate without it. I've seen the question that there are during the calculation about introducing Simpson strong tie connections to our library. I welcome also the company Simpson who's watching as well. We are working on that, even if it's not the topic of this webinar. We are going to have it soon. But this is another module for this design. It's the module limits. But I can lose a little word to that as well. You see that we have a high overloading here. There are two factors that are the reason for this. The first one is I forgot the support here. So that needs to be done by me here. That was not so good. And the second, much more important reason is that I forgot, or did it on purpose, did not activate the average here. So if I go to details, results, say, okay, apply this smoothed internal forces over this area, I would expect much better results, hopefully. So you see, okay, it's still not perfect. I have a high overloading here. We can have a look, but I decreased the number from 250 to 190, and if I look for the overloading in here, so you see this is only on these small peaks here. So that's probably of the high wind we have in England. Yeah, because it gets a lot of bending in there. So that's actually not a singularity point. That's something where you would need a thicker wall. So, and you can see that I'm not often designing in the UK with high wind loads, better say. So let's say we make something like that and calculate it one more time. So you see that was now 6 centimeters thicker, and that gave me actually, okay, now it's too thick, so 16 centimeters would be a little bit too much, somewhere in between. Okay, so from my side, that is all so far. Maybe if I can catch another question that just appeared to it. Ah, no, sorry, I forgot. I said I wanted to mention the design of the support that I will do with the module limits, and that's actually where we will implement the company Simpson also pretty soon. The setup is the same, and if I go to the material database, I can go here to a back-end database, and then let's say I would, maybe use the company Shiger and say I will use nodal support, and then maybe this one, and then, okay, I have only one nodal support right here.
So many thanks again for the modeling in hsbcad and the export and import options that you have seen. I found this very interesting, and also the design that Bastian has shown in AFEM. If you need some more information, please visit our website. You can contact our support by phone or email. And for our American and Canadian customers, we have a local phone number and email. Please note this here on the slide. Please do not forget to request your PDH credits. That's available for all American and Canadian customers. Please contact Amy Heilig with the following email address. And Bastian already mentioned two interesting webinars. So there is a webinar available about cross-laminated timber, and there's also a webinar available about timber connections. And when you are looking for webinars, you just go onto our website, which is dlubal.com, and you find the webinars here under News and Events. You go to Webinars, And here you find a long list of webinars that have been recorded, so you can always watch them on YouTube or download the recorded webinars. And as the one about laminate was back in 2012, you obviously have to scroll a bit further down. And here's also the next upcoming webinar already listed. It's in December, on the 5th of December. We will talk about the warping torsion analysis and plastic design in RFEM. And you're very welcome to listen to this one. So with these closing words, I want to finish the webinar. I just double check if there are the questions are all finished. I think it looks like. So I thank you very much for your attention and hope to welcome you again soon. Many thanks.